Hello, everyone. This is the NMRG meeting. I'm Jérôme François. I'm co-chair of NMRG. My co-chair, Laurent Ciavaglia, unfortunately cannot join us today. So welcome, everyone. So let me remind you some the note well. So just to remind you that NMRG is a research group, but IETF follows the same IETF IPR disclosure rule. So please be aware of that. In particular, if you have some IPR issue, you need to disclose it. Also, it's important to remind you that everything is considered as public here. In particular, the session is recorded and important to know. And also we have a code of conduct that I remind here. So please respect the code of conduct as well. Let me remind although that the goal of IETF is different than IETF. We do not focus here on making standard, but more on long-term research and collaboration. And even if, of course, we can also publish informational or experimental document in the RFC series. So as you know, so this is an online meeting. As already said, the session is being recorded. There is no blue sheet as it will be automatically recorded based on the login in the Meet Echo. Note that you have to enter the queue before saying or before speaking. So please use the button in the Meet Echo to enter the queue. Otherwise, please keep your audio muted and video off. Although as an in-person meeting, it's important that you state your name and if you want any affiliation when you start speaking, just for the at least for the audio stream, but also to be aware who is speaking. Is there multiple people speaking? Here is just a reminder about the different links that we use. It's also the first time in NMRG that we will use the Markdown collaborative tool for the minutes or notes. And I would like to thank Walter Ceroni and Jefferson Campus Nobre for being the minute taker and Jabber scribe. But of course, everybody can also take note in the collaborative tool. So the agenda of today is quite dense. We give the priority today to new topic or recent topic, new contribution, I would say. So we have, after this introduction, we have the introduction of the concepts of digital twin network. I will do then a quick summary of the status of the research challenge in artificial intelligence for network management document. Then we will have two description of use case for IBM, transfer slice intent and interconnection intent. Then we'll have a presentation about service assurance for intent-based networking architecture. An update from the last meeting we had in Singapore. And we have different reports on the participation of NMRG, let's say participant or let's say related participant close to NMRG that participated to hackathon. So we have 3 presentations. And if time allows, we will have some few extra topics. But as I said, so the agenda is quite dense, so I will request that every speaker to really be concise and respect the time. So let's start with our first speaker. So we'll give the floor to Cheng. So Cheng, if you can enter the queue. Yes.
So, Chair, can you hear me? Hello?
Hello, yeah, we can hear you, but very low.
Okay, let me enlarge my speaker. Is it better?
For me, it's still very low. I don't know for other. Maybe I can.
Okay, let me change it.
Oh, yeah, it's better now. Right?
Okay.
Great.
Okay, thank you. So, hello everyone. Hello, Chair. Can I start now?
Yeah, please start now. Yeah.
Okay, this is Chen Zhou from China Mobile, and my presentation is concepts of digital twin network. Next slide, please. This is the agenda for the presentation. It includes background, definition of DTN, benefits of DTN, and a simple case study. Then the challenge of build a DTN system. Then our next plan. Next slide, please. Okay, regarding the background, we know that digital twin is becoming a hot technology in industry, and our purpose is to apply digital twin from industry field to network field. We can see that digital twin has been becoming widely used in industry field such as aerospace, power system, and healthcare, energy facilities, automatic vehicles, etc. However, in network field, digital twin just started since 2018. There are several examples in network field that implement digital twin technology. NetBrain, the company NetBrain his product dynamic maps created real-time network digital twin for Cisco ACI Fabric products based on deep discovery process and mathematical models. Huawei company's NCE product creates digital twin between physical network and the business intent based on AI, big data, and the cloud to achieve full life cycle operation and maintenance. Area networks product step T builds digital twin entity based on teleoperators backbone network and to achieve routing optimization and network failure simulation. Next slide, please. Okay, so far there's no reference or standardized definition of digital twin network. In this draft, we try to define network digital twin as a virtual representation of physical network, analyzing, diagnosing, simulating, and controlling the physical network based on data, model, and interface, so as to achieve the real-time interactive mapping between physical network and virtual twin network. According to the definition, there are four key characteristics of DTN. They are data, model, mapping, and interface. Data is a cornerstone for constructing a DTN system, and the model is the ability source of digital twin network, whereas data model built in a virtual twin network can be designed and flexibly combined to serve network applications. And real-time interactive mapping between a physical network and the virtual network is the most typical feature that DTN is different from network simulation system or platforms. And finally, the standardized interface is a key enabler, which can ensure the capability and scalability of DTN system. Next slide, please. DTN can help enable closed-loop network management across the entire life cycle, from digital deployment and simulation to visualized assessment, physical deployment, and continuous verification. All the benefits of DTN can be characterized into three major types. The first benefit is to lower the cost of network optimization. Without DTN, network optimization has no interactive platform, and it is of longer time cost and higher OPEX, as well as higher service impact on real network. With DTN system, network optimization can be run on effectively on interactive platform for simulation, and it will be with lower time cost and lower OPEX, as well as lower service impact on real network. The second benefit type is more intelligence for network decision making. Without DTN, network management is focusing on managing current data to achieve passive and protective maintenance. With DTN, network management can use AI, big data to analyze past data, current data, as well as future data to achieve to provide more comprehensive decision support to achieve predictive maintenance. The third benefit is data can help achieve high efficiency on network innovation. Currently, there's higher trial risk due to lack of real network for network innovation, and the speed is slow on deploying new innovation. For example, IBM system, network AI application, etc. on for risk adverse network operators. With DTN system, it will be effective. There will be effective virtual twin network, and it will be more easier to access for researchers than to speed up network innovation from prototype to deployment. Next slide, please. Here's a simple case study that DTN can as an enabler for IBM system. We know IBM is being discussed in many SDOs, like here in IETF and in ITU, ATSI, etc. IBM system requires that users' intent can be assured automatically while continuously adjusting the policies and validating the real-time simulation. The figure shows here is the IBM framework suggested by ITU FG Network 2030's architectural document. In this framework, network digital twin is a key enabler in measurement plane. Intent assurance and policy validation can be simulated in network digital twin before control changes are pushed to real network deployment. Next, please. Okay, this page summarizes the key major challenges to build the digital twin network. There are large-scale challenges, capability issue, data modeling difficulties, real-time requirements, and security risks. Since time limited, I won't describe them in detail. Please go to next page. Okay, here are our next steps plan. First, we are to investigate more use cases and requirements on DTN system, and secondly, we are to work on a reference framework on a DTN system. Then we are to study key enabling technologies, including data collection, data modeling, network visualization, etc., to build a DTN system. Even we will build a simulation platform for a small real network. Okay, that's all. Welcome to join our work, and your comments are appreciated. Thank you.
Yeah, hello, can you hear me? This is Albert Cabello from UPC.
Yes, we can hear you, Albert.
Yeah, great, thanks. So thanks for your presentation. I found it super interesting, very ambitious, and quite clear, honestly. I have two questions. Do you are you considering this digital twin technology for wired networks or also for other kind of scenarios? That's the first question. And the second one is how, I understand that this is the next step, but how do you see, which kind of technologies do you think that will be needed to build this kind of system?
Okay. First, the target network is not limited. In fact, it will be include wireless network as well as wired network. So, but as a start, we may start from small network in wireless data center or telecommunication networks, core network.
Mm-hmm.
But overall, there will be no limitation for the digital twin network technology. Okay, that's the first answer.
Yeah. Okay.
And
yeah, go for it. Sorry.
Okay. Regarding your second question, is your second question on how to on the scenarios, right? Typical use cases to use the digital twin system, right?
Yeah, no, the second question was which kind of technologies you think will be needed to build? Because I understand that data collection, data modeling, it's important, but
okay.
But do you want to work with machine learning or other kind of technology?
Good question. Can you go back to the okay? Just stay this. Sorry, just stay next page. Okay. Regarding the key enabling technology, we list here is that data collection, data storage, and network visualization. Of course, in that data modeling is a key technology, and it will include AI technology, machine learning technology, as well as other network topology model techniques, and also interface standardization is a key work to study further to build a unified system to accommodate all devices from various suppliers.
Okay, thank you so much.
Thank you.
Okay, thank you very much, Cheng. We unfortunately have to move to the next presentation due to time constraint. I know that Diego wanted to ask a question, so maybe you can take it offline by email and the mailing list. Thank you.
Thank you very much, and welcome to call me via email. Thank you.
Thank you. So next presentation is about the research challenge in artificial intelligence for network management documents. So again, Jérôme François speaking with the hat of contributor of this document, this time not as a chair. So here we just give an update of the status of this document. So for a few of them, you are now a bit more aware of what there is in the document. So let me remind a bit. The goal of the document is to look at basically what are the specificities of the use of artificial intelligence for network management. So I will not go into the detail of each section that we are now looking at, but basically we wanted first to a bit find the scope of what is difficult problem in network management, where basically AI can help, and then basically try to see what will be the goal of AI to help in these problems. That will be the second, let's say, introduction part of the document. So up to now, we have 7+ contributors. I put 7+ because I know that sometimes there is several people before what has been written in the document. And the core part of the document actually is this one, is the challenge description. So the document is organized with different challenges that people have identified, that some of them have been identified in previous meeting in Singapore or even in Prague before. So yeah, I just tried to a bit categorize them. There are some challenges which are really focusing on the AI technique to be, let's say, to be tailored to network management. So this is in green. Then we identify some data problem. A lot of time we speak about we cannot access data, we don't have label to data, and so on. There are also a lot of discussion, and it's reflected in the in this challenge, which is about the acceptability or admissibility to use artificial intelligence for operating network. So we have different challenge with some overlaps each other. That we need interface and protocols that we need also that it must be explainable to operators what the AI algorithm will do. And yeah, of course, let's say one side or one direction of the that we identify in the different challenges is that for network management, not only for network management, but in our case, it's also the case that we does not need only, let's say, artificial intelligence for extracting knowledge, but we really need to have some operational actions after that. So basically, what we call AI for actions. So here, just again, like I don't have time to go deep into the detail of each of them. For people attending regularly and emerging meetings, some of them has been presented. There are a few new ones that are the, I think, the last three ones. So one is about integrating external events. So meaning that when you want to take a good decision, you cannot only count maybe on the data that you can take from your network, but you also need to exploit some external data. One also is the problem of commercialization of AI-based products that, of course, you can do nice products and nice evaluation in a lab environment of simulated environment. And then the idea is also, can you easily transfer this knowledge or generalize this knowledge to be applicable to another environment in production? And also a more focused topic on the explainability of the artificial intelligence products. That is not only specific to network management, but very important also for us. So next steps, let's say, are the following. So the idea was to create a draft from this. Currently, it's a Google document that was easy for everybody almost to contribute, and then we will create some draft with all the contributors in order to have some visibility to this document a bit more, and to have also some dedicating meetings that we still have to organize to work specifically on the content of the document. Our expectation is to have this first consolidated version. So with because now we have a list of challenges written individually. Of course, we'll try to consolidate that, and we're working on the introduction section. And we would like to have this version for next IETF. Of course, there is a part also about use case in the document, but it will not be the primary focus of this document, and so it will not be for this version. And that's all from my side. So if you have any comments or questions, yes, I will take it. Xuan, I think you asked for screen sharing. If you want to ask a question, you have to enter in the audio queue. Yes, Sheng, please go ahead.
Hello, Chair.
Yeah.
Here's a question, and this is Chen Zhou. And my question is, I reviewed the Google Doc, and in section 3, it is about the use cases, right? And in your current plan, it shows that use cases is not in our short-term plan. Is that correct? We need now just focus on the AI challenges. Is that right?
Yes, it's correct, because we also tried before to collect some use case in different, let's say, activities, or and unfortunately it does not work so well. So because then we just have a collection of use case which are very specific. So in this process, so we want you to try something else, more looking at to the challenge, more in a generic fashion. I know it's sometimes a bit odd, but previous try does not work when we focus on use case, unfortunately.
Okay, got it. Thank you.
Okay, so let's move to the next presentation about transport slice intent. So Luis, yes, good. Just put your slide and then you can start.
Okay, thank you, Jerome. Okay.
Yes, please go.
Thanks so much, Jerome. I will present on behalf of my co-authors, just to also, I would like to highlight that this work has been partially funded by the 5G project. So can you move to the next slide, please? Thank you. So as a summary of the draft, so the target, the objective would be basically to leverage on the intent-based networking technologies for requesting transport slices. So basically to generate slices at transport level. The use case that we do foresee is basically the fact that there will be upper systems processing end-to-end network slices that would require some of connectivity. So basically to create the slices also at the transport level and leveraging on these mechanisms of intent-based. An example of this could be the 3GPP management system that basically could request some connectivity between parts of network slices extending from the RAN, from the radio access network, till the mobile packet core. So having a need in the middle of all these slice parts to connect them and to ensure certain performance, service level objectives, and so on and so far. So the transport slices are foreseen to be requested to a transport slice controller. So the intent-based solution will lie on top of this transport slice controller. So basically feeding the northbound interface of these transport slice controllers. The benefits that we do foresee by using these mechanisms would be the portability of the solution across implementations. So if we move into the intent-based space, we basically simplify the way of requesting slices independently of the implementations that we could have underlie. Also, to have a simple way of expressing transport slice needs. And this could be interesting for the cases of vertical customers, vertical industries, where probably the skills of this customer could not be so much, let's say, technical in this respect. So probably they could find a way of simply expressing needs of connectivity, and also how leaving to the control systems to process, digest all these requests, and basically implement and realize the slices so far. And linked with the point before, so basically focus on what is required, what is needed in terms of slicing the transport level, and not how to implement that. So next slide, please. So the original, or the primary version, the 00 version, was presented in Singapore. So from that point till now, basically what we have done is to clean up the text, also to improve the section on translation approaches. We have updated also the intent definition in line with the adopted draft in the NMRG. So basically we have synced up with that. And also we added Jeff Tansura as co-author, so he's now on board and helping us to move this effort forward. Next slide, please. Yeah, here I would like to to highlight the point that in the TIS working group, there is an ongoing activity on transport slicing. So TIS working group charter and specifically a design team to work on that. And there are several documents being in progress, basically. So definition and framework drafts are basically extensively discussed in this working group, so are close to be ready for adoption. Let's see what happens during this IETF meeting. There is also some other initial work on transport slicing YAM models. There are some alternative models that we need to work more on them to see finally what could be finally defined in this respect. And there is also some additional work on translation of parameters for the node-bound interface of this transport slice controller artifact. So basically what we understand is that this work in transport slice intents would complement the work in TIS by offering this intent-based approach that would be basically simplifying the way of requesting these slices for external customers that could not be so much aware of the technology behind. So basically, we do foresee that this intent-based could assist on these customers to request the slices and feed somehow the node-bound interface of the transport slice controller. Next slide, please. So as next steps, we basically, our idea is to keep developing intent-based capabilities for transport slices. So enter into the details about how we could do, what would be, let's say, the mechanisms for translating this intent-based to that input that would be required in the node-bound interface. I'm probably focusing not only on service, on slice provisioning, and slice fulfillment, but also in the slice assurance. So how to maintain the intent along the time, as long as the conditions in the network are evolving and so. Keep analyzing the attributes in the generic slice template that is being defined in both GSMA. Well, it's been defined, in fact, in GSMA, and 3GPP is adopting this as a generic slice template and particularizing for different specific use cases in what is called network slice template. So basically working about this idea of templates to understand what would be the kind of parameters that could be part of the intent. We would like also to align this work with the progress in this network slicing design team and this working group in general. And we would like basically to request comments from the community for the NMRG group and collect inputs for new versions. And finally, to position this draft as one of the NMRG intent use case according to the work plan in NMRG. If I'm not wrong, this would be corresponding to the work item number 5. And that's all for this presentation, Jerome.
Okay, thank you. Is there any comment or question? So, okay, Alex, I'll give you the floor.
Hello, can you hear me?
Yep.
Okay. Yeah. So I guess So that's interesting. I guess of course the question is where you see the relationship with the slice controller, and given the fact that there is going to be a northbound interface there, basically the question where that northbound interface ends and what the intent basically provides on top, or basically what the delta is. I think that's going to be one of the key questions, and I think this may be useful actually to flesh it out. Basically, how large that delta is. This is not entirely clear to me actually how the two would relate, or if you would basically make the transfer slice controller a basically if that would be itself an intent-based system, or if you view the intent-based system as something northbound basically, and it talks to the northbound and it talks to the controller system. Do you have any do you have a view on that?
Yeah, the normal interface of the transport relays controllers is yet to be defined, but we could expect to have some kind of APIs with parameters and basically ways of requesting SLOs to be committed by the transport network. So what I do foresee more or less, or what I have in mind, is that this intent-based approach would basically translate the request being expressed in the form of these slice templates to basically to the format expected in the northbound interface. To basically doing the translation from one template to the northbound interface. So this is more or less what I could have in mind right now. But clearly, the northbound interface should be defined in the transport relays controller. Once this the northbound interface is defined, probably will be more clear what could be the role of these intent mechanisms for requesting the slices.
Okay, thank you, Luis. So if there is no other question, we will move to your next presentation.
Yeah, it's also from my side, I guess.
Yeah.
Okay. So here I will present a proposition about the usage of intents for interconnection. Let me also here highlight that this work has been partially funded by Phi Growth Project. So if we can move to the next slide, please. So here the idea would be to somehow to reconsider how the interconnection could evolve in the next future. So today, in the present mode of operation, basically the interconnection is conceived only as a pure interchange of IP traffic. So basically the establishment of the setting up of these BGP sessions for transiting and peering traffic from one provider to another. So these environments are typically static, where basically the different operators establish the sessions through an interchange of emails and all this manual setup of BGP sessions and no more than that. So in the future, probably we could foresee that the things will change, basically due to the fact that now the service providers we will have, or the operators will have not only traffic, but also computing capabilities or some other capabilities to trade off and to interchange with other providers. So the current model, so looking just simply to an interchange of traffic, basically limit the capability of interchanging these other capabilities that we could have in the future that are basically enabled by this network virtualization and programmability paradigms that are entering nowadays in the operational networks. So the point is how to realize composite service that could combine compute and network capabilities, traffic from the different operators. So the point would be to find new models of interconnecting in this new era where we could leverage on SDN and NFV, and how to express that in a simple way between providers, between operators, right? So basically, how to deploy or requesting either functions or even computing capabilities for deploying functions and for sure also traffic or IP traffic between providers. So can we move to the next slide, please? So the target of the summary of the draft would be basically to leverage on these intent-based networking technologies for handling and reaching interconnection requests. So not only traffic, but something else. The scenarios of applicability would be, for instance, the interconnection of non-public to public networks in 5G. So again, in these new services that are forthcoming for vertical customers that will have some network capabilities in their own premises, so how to request interconnection to public operators and how to express the needs in terms, again, of functions or cloud capabilities in these public networks and so on and so forth. Also, a second scenario of applicability would be multi-domain network as a service request, and here maybe we could point out to section 4.4 in RFC 8568. And finally, multi-domain network virtualization as is stated in draft Bernardo's NMRG multi-domain 01. There will be for sure other examples. This was just some of them for highlighting the relevance of the case. So the benefits that we could expect is to establish a common and normalized method among service provider for automated interconnection. And again, not only setting up of interchange of traffic, but also connecting to computing capabilities that are in the footprint of other providers. Or functions, not only computing capabilities, also could be service functions that could be in the footprint of other operators, and find a way also of a simple way of expressing a rich interconnection further than pure IP traffic interchange. So next slide, please. So as next steps after this initial version, the idea would be to keep developing these intent-based capabilities for interconnection aspects. So trying to figure out what could be the kind of information that could be part of these interconnection indents. Request comments to NMRG group, to NMRG community, and inputs for feeding new versions to see if there is interest in the group for this. And if so, to position this draft also as a one potential NMRG intent use case, also related to work item 5 in the work plan of the NMRG group. So that's all from my side, Jerome. Thank you.
Thank you, Luis. Is there any question or comment? So Jerome speaking. So thank you, Luis, a lot for your effort for the two use case you are developing now. I think for the last one you didn't get any comment yet, right? It's
no, that was recently posted. So
yeah, it was recently. Okay, that's good because as you mentioned, so now you're one of the next work item for IBN in NMRG is looking at use cases. I'm not sure we have today a lot of time to discuss how we want to proceed with use cases. It is in the extra topic. Anyway, I think what you are starting to work on will be very useful also to maybe then have a common approach for developing use cases and so on. So I think it's so really important for all, let's say, participants interested in IBN and the development of IBN in NMRG to look at your two drafts and give you some comments and feedback.
Okay, thank you.
So if there is some feedback now, it's also possible. We have still some time now. We are on schedule. Okay, so if there is no other feedback, we will move to the next presentation. So next presentation is from Benoit. Okay. And that should work. Let me move to your presentation.
Hello, can you hear me well?
Yeah, perfect.
Very good. So thanks for having me. Today I want to present in NMRG those two drafts that I've been presenting in the past on behalf of many people from different horizons, and you could see the different names and companies over there. The first draft is about an architecture, service assurance for intent-based networking, and the second one, this is about the YANG modules for service assurance. So those two drafts were updated on Monday because we spent some time in the hackathon last week and want to benefit from the feedback over there. Corian will be speaking about the result of the hackathon later presentation. I presented those as well in ObserveWG, specifically because there are Yang modules, so somehow APIs or data models behind it, and ObserveWG seems suitable for that. However, there is a research aspect to this work, hence the presentation here. So if you go to the next slide, and in 10 minutes, I'm going to fly over the issue and show you from a proof of concept what we did. So we know that in the world of config management, knowing that the interface is, knowing that the service configure is not sufficient, we want to know in terms of degradation, where is the fault or the symptoms, because most of the time it's black and white. We have a lot of symptoms and then we could find the root cause. But also what is important is whenever an operator discover like a faulty or degrading component, it's important to understand which services are impacted to be able to prioritize what to solve at which point in time. So this is the idea behind this architecture, in which we decompose the service into smaller components, what we call subservices. And then we've got an assurance graph that links all these subservices together to somehow form the intent of what was intended to be provisioned as a service. And the idea is to assure those subservices, those components, those features independently. And what we do is that we infer, and I want to stress the keyword infer, we infer health score for the service depending on the faulty or degraded component. Since we infer that health score, it's a complementary solution to the end-to-end probing with OWASP or T1 or similar IPSLA protocols, where from there, being threshold based on the one-way delay or packet loss or jitter, we could directly see the real-time experience of the user. So next slide, please. Actually, you could go to slide 5 directly. So in there, in terms of components for architecture, we've got at the top an orchestrator, which is going to configure the services, and we extract those service instances in the orchestrator as an orchestrator, and we are going to deduce the graph, and we're going to have a lot of metrics that needs to be monitored in order to understand the assurance of some components. And those metrics will be, retrieved from routers, switches, virtual, whatever, you name it. This architecture is open, it's flexible, it applies to multiple environments. And then we're going to stream via telemetry the health score and all the symptoms. Okay, and what we want to do is standardize the APIs, what is in Yang in there, to be able to extend this graph, which in the end will be distributed. On the next slide. What we don't plan to standardize because it's just tough. This is the orchestrator. And also the SANE agent. How do we get the assurance of specific components? Some of them are somehow vendor specific, I'm afraid. Now, I want to spend more time on the next slide because this is what I mentioned, that there was like a research aspect to it. So if you go on slide 7, please. And we did the POC. And by the way, the display quality is not great, but you could see at the top of the slide, there are two crossed arrows. And if you click on that, it will be, you will have a bigger definition. All right, and I think it's not for, okay, very good. So let me review the concept of the draft based on this displayed POC. We've got a service at the top, it's a tunnel. And the service health of a tunnel will depend on a couple of things. On the left-hand side, the tunnel interface, which in turn will depend on the health of the physical interface. That depends on the health of the device. That depends on the health of the data plane. And same thing for destination, but also the health of the service will depend on the health of the connectivity, IPv4 connectivity in this case. That will depend on the IGP, in this case ISIS. It will depend on ECMP and the furlough and all this. And we want to assure any of those boxes independently. And you see the top one is orange, so degraded, because some of the components below are degraded. So you see also that there are some dotted lines and some full lines. This is a distinction between informational dependencies and impacting dependencies. At the very bottom, you see the telemetry health. If the telemetry is kind of broken, does it impact my tunnel? Maybe not. However, it's important to know it. Same thing for ECMP. If I see like the symptoms at the right-hand side not fairly balanced, is my service impacted? Is my customer impacted in the end? The answer is, I don't know. However, it's a good symptom to have. And what you see, the list of impacted services on the right-hand side, is that since I've got the graph top down, I also have the graphs from the reverse direction, which means that if I click on the ECMP furlough as I did, then you will see all the services that are impacted. And all this is based on Yang, where you could add the dependencies as you wish and group distributed graphs. So if you go to the next slide, what's changed is that I stressed in the document that this is an architecture which is open and flexible, so it's applicable to a typical networking service, but also to wireless, to 5G, and to Vim, a virtual infrastructure manager. As long as you can extract somehow the service or the intent from the orchestrator, then you could have this graph. And the next step is to be able to group those distributed graphs together. We also stress that NTPs require over the place. It's kind of obvious if you do fault management. And we introduce a notion of symptoms history start, because if you start collecting all these symptoms, maybe because you want to inject that into your big data lake along with machine learning and see what you could get, then we wanted to know what was the start time for symptoms for a specific subservice, either because you just started or because there is some garbage collection process and you have to get rid of older ones. Okay, on the next slide. What we learn, and maybe it's getting too much into details, but what we learned from the hackathon is that we've got a nations graph version and the last change. And we keep that basically for post-mortem. Right, if you had an issue yesterday that you want to troubleshoot, you could give a history of this assurance graph along with all the symptoms. And the specifications were not that clear because we have two mechanisms to do so, and we make those fields compulsory. We also explain what a change means, because just saying I've got a new version of the graph, right, but what is a change? It's a dependency, it's a status, etc. And we rename also label to description, because when reading the Yang model, we realized there were like two different concepts called labels. All right, and the next and last slide, I want to be respectful of the time, is that feedback is very interesting to us. Maybe more feedback to not only to the draft, but also to the open source code that Corian will be sharing later in this session. And for information, as I mentioned at the beginning, we are considering workable option in ops LWG. So with this, I'm not sure if there is time, but I welcome any questions or comments.
So thank you, Benoit. I think Alexander has a question.
Yes, hello, Benoit. Interesting stuff. I saw also your presentation.
Alex, please just restate your name, please.
Oh, sorry, this is Alex Clem. Yeah, so I do have actually one thing that I observed. So basically what you're suggesting is a model-based reasoning type of approach to inferring the health and so forth of service instances. Now, one of the problems with these model-based techniques is typically it requires a complete model in order to really basically get useful information up there. And if it's not complete, it is very hard to actually refer the true status, because there are so many things that you cannot capture. So therefore, while such a model can be very useful in the dependency chains, it can be useful to diagnose and to troubleshoot and use that as a starting point. The question is how much it can substitute actually monitoring this higher level concept itself. So now when you say, I use this to infer how healthy this is, and I don't do this by observing the entity but I do it just by observing what my model thinks that how the components that go into this are doing, that basically risks that you don't have an accurate picture, right? I mean, unless you are very certain that you have captured everything in the model that could possibly impact this higher level concept. Do you have a comment on that, or how are you tackling the model completeness? And yeah.
Good question, Alex. Thanks. So first of all, what is a typical way to do monitoring these days? Is that we just look at synthetic traffic, probing end-to-end, and we just say, okay, there is something wrong. But you consider network as a black box. And a trace trial will not help you to see there's an issue with ECMP or with the QoS, whatever. So now what we're offering here is the reverse direction. We try to assure components by components, right? So at least in the slide 7, something which is important is that, if you go back to slide 7, is that we are able to tell where the problem is not. So if we say we monitor the interfaces and they're part of the service and they have no problem, so this is a good thing already. Now to come back to your point that we need the complete graph, the more complete it is, the better. Obviously, based on my previous point that any of the components that you could exclude from the troubleshooting is a step in the right direction, this is helping. Does it make sense?
Sure. Yes, I think I'll probably send a follow-up email perhaps on this, so we can have a little bit more discussion on this than we can in this forum.
Yes, please.
Thanks.
Thank you. And one last thing I want to say is that if we conclude that there is an issue with, an orange tunnel interface there, and I didn't cut and paste the symptoms there, but basically this is something like there is no traffic on the interface, right? And again, this is like a symptom which is related to that component. And now we could do closed loop automation to say, I have to correct that specific interface component wherever it is.
Sure.
Shang, if you have a question.
Hello. Hello, Bernard.
Yes, we can hear you.
Okay. One question here. This is Chenzhou. My question is that in your POC, is there any effectiveness data of your POC? Like what's the percentage of the correctly diagnose the failure, and what's the percentage of the ineffectiveness of diagnose any failure?
All right. So the first part of the question was: is there any data in this? Yes, it's a live network, and actually we've got multiple networks. One part of the network being virtual and one being physical routers. And yes, there's real data. Now you ask a very good question: is how do we know if this is efficient, right? How do we know if we discover the right problem? I think that in the end, whenever it will be into operational network, The only metric that counts to me is if we're going to help the support team, the operational team. And somehow, based on the feedback, you've seen like multiple operators being involved there. Based on the first feedback, this is helping a lot. As I stressed before, because we're able to say what the problem is not according to our needs. And if I take, for example, a device there, right, and a device is red, okay, sure, there is a vendor-specific aspect to it. So I work for Cisco, and I should be able to tell if my Cisco router behaves correctly and not asking every single of my customers to pull or stream the CPU, the memory, the Ceph entries, and all this. So somehow, my customer should be able to rely on me to discover what's wrong. And if I combine this with my support teams through which I'm receiving all different calls, then I could guarantee that I've got some results. So the number of calls received in Cisco is also like a good metric.
Okay, thank you. Thank you.
Thanks to you, Chang.
Okay, thank you, Benoit. I know that Holga has also a question, but I recommend her maybe to send you an email because we have to move on to the next presentation. Thank you very much. And yeah, okay, good. We have somebody to be JavaScript because we lost our JavaScript. Thank you very much. So next presentation is a continuation because it will be the hackathon report from Korean.
Hello, can you hear me?
Yes, great. Just
okay.
do some.
So my name is Corian Edeline. I am a postdoc at the University of Liège. I've started 5 months ago, and I'm working on service assurance for intent-based networking. Slide, please. So we participated to the hackathon with the initial objectives of doing assurance for a VPP service. So VPP is a user space packet processing software. We wanted to leverage the SEN architecture and YAN modules to do so. As collector, we envisioned PMA-CCT and or Telegraph, and as additional component to the SEN architecture, we envisioned InfluxDB, Grafana, and or Chronograph. Slide, please. And the core component of the SEN architecture that we use for the hackathon is this open source SEN agent that I've been developing for a few months, and which comes with 2 visualization tools. So the agent can be described in 3 steps: inputs, metrics, and rules. So first, the inputs aims at discovering data sources and gathering data. So by discovering data sources, I mean, for instance, enumerating hypervisors APIs and then pulling data from VMs. So this is the same logic that you apply to different data sources, such as the /proc, netlink sockets, GNMI-based interfaces, or basically a lot of interfaces, a lot of APIs. Then, of course, these data are vendor dependent. So the next step is to normalize this data into vendor independent in terms of name, in terms of unit, and in terms of type. Also, the second step aims at discovering subservices and their dependencies. So let's say you run a DX agent on a node, you discover it has networking subservice, you discover it has N interfaces, and that this interfaces is running DNS service, DHCP service, maybe ECMP, and this and that. So this is what you discover, and you establish the dependencies accordingly. Then the last step is the rule step, which aims at applying conditions or rules on normalized data in order to derive symptoms, in order then to compute health scores for subservices and to propagate health maluses along dependencies. You are able to access this data via shared memory by using a basic Ncursus console app, and also by exporting data using the IETF service assurance YAN model through GNMI in a JavaScript-based web app. Slide, please. And this is what it looks like. It's pretty small, but on your left, you can see the the console app. So this is the screen of the metrics, so the vendor independent value. At the top, you see the red lines, which are the positive symptoms. And you can see as argument the full denomination of the node that triggered the symptom, which would be the subservice. And on the other side, you can see the graph dependency, the subservice graph and the dependency. So nodes are subservices and edges are dependency. So you can see how the else maluses propagate along edges. You can play with it because it's in JavaScript, and you can use it to dig for root causes. Slide, please. So the critical part of this tool is the rule engine, because this is what it used to highlight symptoms and to derive health scores. The idea is to leverage subservice expertise to highlight anomalies or health problems via rules. You can define rules based on variables, which are the vendor independent metrics. You also have basic operators at your disposal, alongside more complex operators, which analyze temporal aspects, which allows to select or to extract how a variable has evolved over time. So at the bottom, you can see examples of rules. So you have a string that describes it, a node to which it should be plugged and checked, a severity, and then the actual condition. So for instance, the first will be positive if an interface has changed states up to down to up 6 or more times on the last minute. But you can also compute buffer occupancy ratios. You can check for specific error counter increments. You can do basic thresholding, or you can also combine rules together, such as the last one, which is checking for inconsistencies between MTU and interface type. Slide, please. So I believe this is a very promising approach, which has a lot of use cases, and a few that Benoit have described. So for instance, if you have this networking company that has a lot of network devices on which you install a SANE agent, then you have it. Then this company is providing service for a client that require a subset of those network devices. You can simply collect the assurance graph from those devices, concatenate them to build your client service assurance graph. And by monitoring the top root node health score, you are able to have a hint on your client service health. Of course, you can also use it for other purposes, such as identify the consequences of a component failure. By, for instance, using the web app, you can directly find which subservices are going to be impacted by the failure or which clients. And finally, you can also use it to monitor multiple unrelated subservices. Slide, please. So in the hackathon, so this is the open architecture for SANE. Slide, please. In the hackathon, this is where the components were positioned. So monitored entity was a VPP in a VM. SANE agent is DX agent. The SANE collector, we envision Telegraph and PMSCCT, and the visualization tools are already said. So slide, please. So this is an example of the result that we came up with. This is Chronograph doing health monitoring in real time of the VPP instance, which is here at 100%. A slide, please. So here you notice a health score decrease. Slide, please. And you can use the tools to dig up for the root cause. For instance, use the web app with the node as a GNMI target. And as you can see, you can find the red path pretty easily and find that the source of this health score deterioration was, it's pretty small, but you can see DPDK allocation error and no free huge page. So it can be fixed by simply allocating more huge pages. You could also have used the console app, but it requires SSH access and it is less visual. A slide, please. We also did more work on interoperability by with Alexandre Leonardi adding DX agent support for DX agent exporting to the Cisco SANE POC collector. which is based on a pipeline. Slide, please. And finally, the next steps for me are to work on a more complete rule engine to increase the versatility of the rule expressions, because it's very important. Then I'm going to consider the addition of end-to-end probing tools as input sources to have some kind of empirical view of what is going on in the network. Then the next big step is this multi-node assurance graph concatenation architecture, which is probably going to be interesting. There is also parallel work by Canan to add GNMI support to PMA-CCT, which would make the DXagent interoperable with PMA-CCT. At one point in the next month, I'm going to work on a paper on a specific use case of this same agent. And finally, I believe the value of this tool relies on the amount of input and on the amount and the quality of rules. So any contribution is warmly welcomed. Feel free to contact me or to do the classic clone, hack, and pull request. Thanks.
Thank you, Corian. Comment or feedback? Okay, may I ask you a question, because it's actually to both you and Benoit, because I remember that Benoit said that a hackathon was also helpful to revise the document. I was wondering more perspective of how hackathon can help the development of drafts. So can you, either you or Benoit, say what was helpful for the document after the hackathon?
Maybe Benoit can answer.
So I believe I'm online. Can you confirm?
Yeah.
Okay, so the best thing to do is to take the two drafts I mentioned before and to look at the diff. So for example, we explain what a change is whenever we do like a new version, a +1 in the assurance graph version. We explain what a change is. We explain how to process this from the agent, from the collector. We change some Yang modules, some Yang leaves as compulsory. So this is mainly covered maybe quickly, or maybe we should have done in a reverse way on slide 9 of my presentation. We had to rename also like labels.
Okay.
These are learns and also a couple of things that are more implementation specific, because as Corian mentioned, he was able to send his DXagent to what we developed internally in the POC I've been sharing, and we're able to see the information. So it was exchange of information in both directions. And we spent only a day on this one, as opposed to a week for the hackathon. It was anyway very efficient.
Okay. Please, Andre.
Thank you. My name is Andre Bondi. I'm a performance consultant. I have dual questions. The first is, have you thought about how often you're going to be doing these probes to collect information about what's happening in the system? Because there's a cost to that, and also there is a response time requirement of some kind on the analysis so that you can intervene when you find a problem quickly. The second question is whether the frequency with which you're collecting the data is commensurate with the time scale within which the problem is going to occur and whether it might go away so that it doesn't matter, because many of, in congestion control, for instance, a lot of these things are transient.
So I can answer on the frequency of data collection in the DX agent. So it's configurable. As of now, it's 3 seconds. And in terms of system overload, this is something like 10% CPU every 3 seconds.
Thank you. Yeah, it's just something that needs to be thought about, because it seems to me as though that this is going to cover a broad range of problems. So we want to make sure that the time scale is commensurate, and also that the overhead of doing this doesn't itself drag the system down.
Yes, of course, you are right.
Okay. Thank you.
Am I online? It's not too clear. Can you hear me?
Yeah.
Okay, very good. So I want to also answer the first question. So actually, Andre, is going to depend on the subservice and what you try to do. So whenever we speak about probe, for me, this is mainly like synthetic traffic, right? End-to-end probing.
Mm-hmm.
And this one, yes, we have got a large scaling issue, N-square issue, and specifically whenever we want to monitor like the loss, the packet loss. Now, what we do here is streaming information on a regular basis from typically routers or virtual machine, etc. And it's going to depend on which use case we try to do. So if I take 2 QoS, well, sure, you want to run it earlier. If we take like the stability of routes in an IGP, well, it's important to understand if you get like a delta plus or minus, let's say 5%. Now, is this critical that you have to know it like at a millisecond? Maybe not. So it has to be configurable per subservice. And I would say subservice type. And if done right, and this is why we did the graph, is that every single component is monitored a single time, which is, by the way, what we're trying to avoid, that in the past, every single NMS would pull the interface counters just because it's the right thing to do, people believe. But in this case, the monitor would be self-monitoring itself.
Okay, so you're going to be relying on traps rather than poles in order to minimize the amount of activity that's going on.
I'm going to rely on model-driven telemetry, because the traps, which is based on SNMP and MIPS, doesn't provide the right data model that I need. We have to make sure data model that we need is the same one which is used for configuration. And since YANG is used for configuration, we must be using the same YANG for streaming telemetry. So model-driven telemetry. Makes sense?
Yes, it does. Thank you.
Thank you, Andre.
Okay, last question from Diego.
More than a question, it's just a comment. Precisely what I'm saying is that we are in data aggregation and data composition. So you could have some kind of, I don't know how to call it, buffering or data backplane, so that would alleviate as well overloads and all the like. It's not that you have to go down to every single component. In many cases, what is could become more important is in these models is data aggregates. We are playing with that idea, something that we presented in the interim, and we are thinking how to connect this with the whole saying architecture. This is ongoing.
You're fully right. There is data aggregation. If I take back the example of the number of routes, right? As I mentioned in that case, you want a delta of number of routes from IGP to pretend it's stable or not. And this is why we sometimes need things such as a baselining, right? Which is somehow a different view of your data aggregation. And if there is a delta compared to the baseline of number of routes, then we report a symptom. So fully agree with you, Diego. Data aggregation is key here.
Okay, so thank you very much, Corian and Benoit. And we move to the next presentation. So Walter, yes. Okay.
Hello, can you hear me?
Yeah, perfect.
Thanks.
Just put your slide. Okay, you can start.
Thanks, Jerome. And thank you, everybody. I'm Walter Cerroni from University of Bologna, and I'm presenting the short report on what we've been doing on the hackathon about the multi-level approach to IBM. This is actually the first time ever, I think, that NMRG was proposing a project to the IETF hackathon, and it was also my very first time for this kind of event. Being this an activity coming from a research group, it was less, let's say, focused on standard development or standard testing on interoperational testing. It was basically trying to prove an idea of this multi-level approach to IBM. Next slide, please. So the problem we were working on is related to, of course, intent-based networking. You can read the definition that is given in one of the drafts that's being prepared by the group here. There are actually two drafts that were involved in this demonstration. One is the one related to the concept and definition, which that actually definition of intent refers to, and the other was about the intent classification, because we are dealing with different level of intent. So this is actually a very important way to see if the classification is actually fit to the ideas that we have. Next slide, please. So the specific problem that we wanted to solve was to apply the intent concept at different levels that actually may correspond to different stakeholders. So we came up with this idea together with the other people that have been working with me to have an infrastructure provider that basically provides some sort of slice intent interface, a service provider that actually consumes that slice intent and on its own provides a service intent to customers, and then customer or vertical services that actually consume those service intent interfaces. I think this perfectly fit with the presentation that Luis gave earlier about the slice intent, the interconnection intent. That, I mean, we've been working on this before we were aware of the work by Luis, so I see definitely some important connecting point here that we are going to definitely look into in the future. So how did we plan to solve this problem? We basically prepared a proof of concept in an NFV framework. This proof of concept was actually the result of collaboration between our research group at University of Bologna and Barbara Martini's research group at CNIT Italy. We've been working on this concept for a while. It's also a consequence of the demo session that we have in an NMRG meeting in last October in Rome, where we try to put together our ideas having this kind of intent interfaces at operating at different levels. So we were able to make this proof of concept. We were able to demonstrate actually how we could set up first a slice intent and then some service intent on top of that. And of course, we did that on a simplified scenario, which was the one that we were playing with during the hackathon. Next slide, please. So basically, the idea, as you can see on the left, we have some customer that want to require service chain. We are focusing on the case of service chains, but I think this approach can be applied to also different scenarios. They ask for services to service provider that in turn they ask slices to infrastructure provider. And then you can see in the middle how different intent interfaces must be located in this architecture. So basically, we define on one side the slice intent, which is used to express the request of our network slice, which is composed of a set of top layer virtual functions that basically implement network appliances even at higher layer, or simply vertical applications. And then a set of virtual switches or routers that actually build the connectivity, the virtual connectivity in the slice itself. And then this is what we call actually the slice intent. And then on top of that, we have the service chain intent, which is used to express request for a service operated through a chain of components. So basically, the idea is to specify how you want to compose a service given those components offered by the slice. Next slide, please. So we did successfully demonstrate the proof of concept. As I said, this was actually the result of the joint work by myself and David at Unibo and Barbara and Molka at CNIT. And also, thanks also to the discussion that we have in previous NMRG meetings. We actually didn't have the chance to do any hands-on collaborating work. Probably the project is still not mature for that, and maybe we will be able to do that in future events, future hackathon events like this. But we had a really fruitful discussion on the system itself and on the idea and on the next steps. There were some people involved that I would like to thank because they offer very good suggestions. A few comments came from Ferhat and Navid about their approach, how to integrate actually our idea with their approach to express high-level intents that need to be translated in something that can be mapped in our solution, for instance, because we basically make a sort of mapping between a high-level intent expressed in JSON format to network function and network service descriptors in the NFV environment. So a next step should be actually how we can actually express the intent in something different, in a different language that can also be translated into what we are doing in the lower layer, let's say. And also, we had also good discussion with Olga of how we can actually classify the approach that we have according to the intent classification work that they've been doing in the draft. There is a link to the video session, to the video recording of the session. We recorded all the sessions, so both the presentation, the demonstration, and the discussion afterwards. So if you're interested, you can follow that link and then you have access to the video. Next slide, please. Talking about intent classification, we actually, as an outcome of the hackathon session, we tried a first attempt to follow the methodology in the draft about classification. So basically, based on that, I'm going through this quickly, then we can have a discussion offline if anyone is interested. We consider this approach that could be both a carrier and a data center solution because we are actually focusing on NFV approach, an FV scenario. And then the intent use type, those are the elements defined in the draft for the intent classification. So we basically, as in terms of intent user types and type of intent, I think we consider two different selections, two different types for slicing intent and service chain intent. Again, this is just a first attempt, so maybe it needs more discussion, further discussion. But I think we could better discuss this with other people and then came up with a full classification of our intent. Also, we found some correspondence, some good fitting with also the intent scope, network scope abstractions, and so on. Next slide, please. So what we learned, basically, there is a need to bring together diverse background and expertise, and I see that there is some activity going on, especially from the presentations that we had today, I mean, in our case, there are still a lot of things to be done that are not there yet, like the intent translation refinement. This was what I was talking about before. The validation, monitoring, observation, interaction with transport networks, and I see that several presentations before this one were actually touching those points. So we will definitely need to get in touch and to look into the draft being developed on these topics, because this will really help to build a complete IABN, and of course extend implementation our use case to a more complex scenario, including multiple VIMs and multiple point of presence. Next slide, please. So this is just to conclude. I would like to thank all the guys that helped me in working on this demonstration and this hackathon session. Davide, Molka, and Barbara, especially for their help. All of us were first timers, so that was also a very good experience for us to learn what and how we can work on this kind of events. And again, if you're interested, of course, I'm here. If you want to ask any question, I'm available. But again, if you're interested to look into the session, it has been recorded, and then you have the link over there. Thanks.
Thank you, Walter. Is there any questions, comments? Yes, please, Olga.
Yes, hi. Just wanted to say thanks to Walter for adding kind of the taxonomy, and it is good to know that we don't need any additional categories. So we will follow up after this meeting to see from their experience what's the best way to kind of present that kind of information for POCs going forward. Thanks, Walter.
Yes, thanks. Actually, as a first attempt, we basically were able to select all the options that are already there in the draft, and we didn't think about any missing. I mean, at least this is not what we had in mind. So there's not seem to be anything missing now, but maybe we need to think about more about that. So, but we can definitely follow up on that.
Yeah, thanks. Thank you very much.
Okay, I think there is a question on the chat. It says, does your approach allow multiple levels of intent beyond the two levels? Well, this is a good question. It could. I mean, we were thinking about the use case of, a physical infrastructure provider, a virtual service provider, or a virtual operator, let's say, and then a service customer, let's say. So that's why we focus on two levels. I think it depends on the level of abstraction. So maybe this can be extended to multiple levels, especially if maybe the infrastructure is made of different, I would say, sub-infrastructure or different segments. Maybe you can have multiple levels also at that layer, because you may want to express something that encompasses the whole infrastructure, and then maybe you need to map that or decompose that into intents that relates to different segments. So this is a possibility, definitely.
Okay, thank you, Walter, and thank you for the comment. Let's continue with the last presentation from Paul. So Paul, I will grant you audio and video, and we'll put your slides.
Hello, Jerome.
Hello, Paul.
Yeah, good, thank you. So I will quickly present the 5 minutes. Okay. So basically, today I will introduce I2NSF work related to intent-based networking. So basically, I2NSF framework is a good example for IBM. Next slide, please. So this figure shows the architecture of I2NSF. Basically, video client car can get video stream from a video server using a chain of network security functions. This kind of service function chaining of security can be configured by I2NSF framework. Next slide, please. So I2NSF has 3 interfaces. First, registration interface is used to register capability of a network security function with security controller. Secondly, consumer-facing interface is used to deliver high-level policy from I2NSF user. I2NSF user is network security administrator dashboard. And lastly, NSF-facing interface is used to deliver specific low-level security policy from security controller to network security functions. Next slide, please. This hackathon, we reflected the latest revisions of the following draft, the capability data model, and 3 major interfaces, also security policy translator. Next slide, please. This figure shows basically the bottom, the administrator deliver high-level policy such as SNS, some policy such as the company employee cannot access SNS website such as Instagram, YouTube during work time. After work time, they can access. So we implemented our I2NSF system on top of NFV architectural framework. So please refer to this our latest magazine paper for detailed information. Next slide, please. So this is the shows the procedure of the policy enforcement. So next slide, please. This figure is very important. So I think this is most relevant to NMRG. So basically, I2NSF user deliver high-level policy such as employee cannot access during work time. So security controller has a security policy translator, consists of 3 modules: data extractor, data converter, policy generator. So data converter extract high-level policy into high-level data, and the data converter converts high-level data into low-level data. And finally, policy generator construct XML file that is low-level security policy. Next slide, please. So during this hackathon, we used this network topology with this open source, especially OpenStack, and the minimum specification you can see. Next slide, please. What we got done, so we restored I2NSF framework on top of OpenStack, web-based I2NSF user, console-based security control, and developer management system, that is DMS, and also security policy translator was used. So also we reflected the latest revision of data young models. Next slide, please. So what we learned, we recognize the importance of security policy translator to support IBM-based security services. So currently we developing automatic mapping between high-level Yang attribute and the low-level Yang attribute. Secondly, we are planning to develop the installation of low-level Yang production rules to generate XML file for low-level security policy. So next steps, we implement the two things. This coming November hackathon project, we implement two things. Next slide, please. So this shows our open source project. You can get the open source. Also, we put a demo video clip into YouTube. Thank you for your listening. Any questions or comments? Okay, that's all. Yeah.
Yes, please, Charles.
Can you hear me now?
Yeah, I can hear you. Yeah.
Sorry about that. Hey, great work with this hackathon project, and thanks for sharing it here. One question that came to mind looking through your presentation, I've seen that this group has done quite a lot of work with the I2NS framework on top of OpenStack. Is there any thought to make a contribution to the OpenStack project to actually get this incorporated as a an additional component to be used with OpenStack, because that might be a really good way to make the I2NSF framework more available to a larger community outside of the IETF.
Okay, Charles, yeah, that is a good suggestion. So yeah, I will seriously consider to contribute to OpenStack. So my colleague, you can see Sungseo University Professor Young-Han Kim, his team is mainly working for OpenStack. So I will discuss with him how to contribute to OpenStack for our IETF staff. Also, maybe you can give me some guidance to contribute to OpenStack society. Okay.
Yeah, certainly. Happy to follow up with you after the meeting.
Okay. Thank you, Charles. Yeah.
Okay, thank you very much for your presentation. We are now at the end of the meeting, unfortunately. Of course, we cannot cover the extra topic because we have no more free time. So we, the chair, me, and Laurent will approach the other proposal to see if there is something to disseminate through the mailing list for people who unfortunately cannot present today. But of course, I would like to thank you all the presenters and the attendees for the NMRG meeting. And minutes will be, of course, published and so on. So thank you very much, and talk to you soon. Bye-bye.
Okay. Thank you. Bye-bye.
Bye.
Bye.
Take care.